Good morning, boys and girls. Mr. Giomini sitting here in Academic Extension with a lovely group of, 8 kids. We're going to model for you the evening practice for tonight on Con. It is a bit more challenging. It involves a little more thought and just some careful time and not rushing things. So let's work with writing expressions with exponent word problems. So I'll click on that, and I'm going to make this a little bit larger so you can see. Oh, I already got one right. Awesome. Let's take a look. Let's make this a little bigger so we can see. Taking a look, it says, Boomtown was established in a remote part of the world in 2010. Its population has doubled every year since its founding. If there were 1,000 people in Boomtown when it is established, what will the population be after, or what will be the population after 6 years? Write a numerical expression with exponents to describe the population of Boomtown after 6 years. All right, so let's take a look here. Let me get some scratch pad here, help us out. So Boomtown started back in 2010. We don't really need to know the year right now. That's not of importance. We do need to know that it started off with 1,000 people. So whatever I begin to add on, we always know our base is 1,000. So I'm going to put 1,000 here. Now, what I also noticed is that it's going to double every single year. Is that what it says here? It'll double every year. So we know the population is going to double every year. And they want to know what's the population going to be, what will the population be after 6 years. Okay. Now, if I know that after 1 year, let's think about that first year of Boomtown, and we're doubling, so we're timesing by 2. 2 to the first, or 2 to the, what do we say, 2 to the 0 power? Is 2 to the 0 power? What's 2 to the 0 power? Isn't that just 1? Isn't that just 1? So 2 times 1,000 would give us what? 2,000? Now it's going to, how many years is it going to double for? Is it 6 years? So what if I did, let's see, if I took 1,000, it multiplied it by 2 to the what power? Because we're doing it after what? 6 years? Let's see if this works. What does 2 to the 6 power mean? Does it mean 36? Or what does 2 to the 6 power mean? What do you got there, Frank? Two times 2 times 2 times 2 times 2 times 2. So 6 2s. Let's see here. 2 times 2 times 2 is what? 8. And then I have 2 times 2 times 2 is what again? 8. Now I have 8 times 8, which is, what's 8 times 8? 64. But then I have to times that by the what? By the 1,000? So it would be 64 times 1,000. So what would be 64 times 1,000? 64,000. Now let's see here. It says write a numerical expression. So let's see. We start with 1,000. Now would I times that by the 64,000 or add it? What do you think I do? Times it. So times like this and then 2. Now how do you do an exponent with con? It'd be the caret button, which is right above 6. And then actually 6. So let's see if this works. We had it right. Okay. That answer kind of makes sense, or how we went about that process. Let's look at another one. Nona, beautiful name. Nona is making 3 square posters for every class for the class election. One poster has side lengths of 50 centimeters. The other 2 posters have side lengths of 60 centimeters. Write a numerical expression with exponents that describe the area in centimeter squares of the poster board Nona needs for all 6 posters. Now, each poster will be what shape? Square. All right, and we have 3 square posters. Now, I'm going to draw a little picture. I have one poster here, another poster here, and another poster here. Well, what's the length of the one poster? 50. Now, what do we do to find the area of a square? How do you find area of a square? Area equals what? Length times width, right? Or we could also write it like this, because the square, both sides are congruent, correct? So can I do this? Area equals just the length squared. Okay, because this is going to be 50 and 50, so 50 squared. These both are how long? Because she has 2 other posters that have a measurement of what? 60. So that's 60 and 60 and 60 and 60. Now, how can I go about writing a numerical expression using exponents? Well, the first one would be what? 50 raised to the what power? Squared. And then would I add all these posters together, or multiply them all? It says find a total area. I'm going to add them. So plus, what's the other one? 60 to the what power? second plus another what? 60 to the second power. So let's see if we get an answer here. Okay. We'll do one more of this and we'll go another one. You have two tubes, or cubes, excuse me, that you will fill with water to make ice cubes. The first cube has sides of length 6 centimeters. The second cube has sides of length 5 centimeters. Write a numerical expression with exponents to represent the total volume of the ice you can make in cubic centimeters. Now, numerical expression, so it's not algebraic, no variable. Now, anybody know about volume of a cube? What's the formula for volume of a cube? Anybody know? Salad? Love it. Length times width times height. Now, Katie, what do you notice about all these ice cubes? We have two of them. The first cube has all being sides being what? 6. And the second one has all being what? 5. So aren't these all then going to be for the first one? Let's go for the first one. This would just be what? 6 times 6 times 6. But how do I write that using exponents? 6 to the third? Nah, good. And then Frank, the next one has ice cubes all 5, right? So if we know that volume, as Katie told us, is length times width times height, this is 5, then the width would be what? 5, and the height would be 5. Well, how can I shorten that and condense it? Instead of writing 5 times 5 times 5, I could write 5 to the what? 5 to the third power. Now, Lucas, you had your hand up. How can we find the total volume of this? What could be the expression? There's we wrote. There's our exponents. If I want to find the total volume of these, what would I do? I don't want to find how many times more. I just do what? I like 5 to the third power. I agree with that. What's that? Yeah, 5 to the third power plus 6 to the third power. And that should give me the total volume. Let's take a look. All right. We okay with these? That makes sense? You just got to take your time. Now, the other con skill, similar. It's called evaluating exponent expression word problems. Okay? So we did the writing. Now let's take a look at this one. You should see some similarities here. This one I saw Sean trying to do this morning by taking a piece of paper and folding it over and over and over and over. Samurai swords are made by repeatedly heating a steel bar, hammering it, and then folding it in half. The process creates a sword with many layers. Each time you fold the steel, the number of layers doubles. What is the number of layers in a piece of steel that has been folded 7 times? Well, let's just take a look. Let's say I had my sword here. Oh, can I do scratch pad here? There it is. So let's take, I have my sword here, and I fold it once, correct? So I double, so it would be 2 to the what power? First. No, I only fold it once, right? So what is 2 to the first? It is 2. If I fold it twice, if I fold this over, I'd have what now? 4 pieces, right? Well, that'd be 2 to the what? Second, and that equals what? 4. Now I'm going to fold this how many times? So it's going to be 2 to the what? 7th. But it says, what is the number of layers? So I can't write in 2 to the 7th. I have to go 2 times 2 times 2 times 2 times 2 times 2 times 2, correct? Well, let's see here. 2 times 2 times 2 is what there, Klima? That a boy. 2 times 2 times 2 is what, Evan? 8. And then times 2. Well, what's 8 times 8? 64. And then I'll double 64. So 64, oops, 64 doubled. 128. We agree with that? Ayo? All right, let's take a look. 128. All right. Let's see here. The surface area of a cube is equal to the sum of its areas of 6 sides. So surface area. Here's my cube. I'll make a very ugly cube real quick. All right. Now it says each cube's face. So we're talking about a cube that's each face is a square. And we know how to find the area of a square. It's just length squared. Now this one's saying each side is 6. So there we go. Jake has 2 cubes. So Jake has 2 cubes that he wants to paint. One cube has side lengths of 3 units. The other cube has side lengths of 4. What is the total surface area that Jake needs to paint? Well, so this side it says surface area is 6 sides. So let's change these. It just has 6 sides. This is all 3, 3, and 3. So what would the area be of this side? Let's just look at this side. What's the area of that side of the square? Remember, area is just essentially length squared. So what's the area of that side? What are the dimensions of it? 3 by 3. So what's 3 squared? 9. Okay, so we know that area for this is 9 because we did 3 times 3. But how many faces are on this cube? How many faces are on that cube? Heller, how many faces are on that cube? How many faces are on the cube? There you go. And Heller, each face has an area of 9. So if I want to find a total area, I just go 9 times 6, which gives me what? 54. Okay, so that's for this square. I figured out this one. Check. But the other one has what? Each side is what? 4. Now, I have one square that is a 4 by 4. So, Dill, what's the area of this square right here? 16, because we know find an area of a square, we could do length squared. So that would be area equals 4 times 4. That is 16. But Dylan, how many squares make up this cube? There you go. So what do we have to do with this 16? Times it by 6. I think that gives me 96. And what do I do with these two numbers to find a total surface area? Add them. I mean, you know what 54 plus 96 is? I know 6 and 4 is 10. Let's see, 5 and 4, isn't that 14? 15, so we got 150? Does that make sense? Take a look. Okay, we're all right with these? So that's how you approach these con skills. I'd be glad to help you out today, and hopefully this video helps you out as well. All right, take care.